Today, with this presentation, we will cover a new tools that we introduce in MapStore, in particular in the 3D environment. This one, yeah. Before to start with the tool itself, what's MapStore? MapStore is a framework, WebGIS framework, that by itself provides a product that is a WebGIS that you can access through the browser. Today we will see mainly the map viewer, so the application that allows you to compose through layers a map visualization. Currently there are three main implementations in MapStore: OpenLayers, Leaflet, and Cesium.js. The one that we will focus today is Cesium.js and the functionality that we introduced with the latest plugin. So, improvement done on the 3D side. The update of the Cesium library to the latest releases to add support of 3D tiles, in particular also 3D tiles related to the Google Photorealistic 3D tiles provider. This map views that it's a tool that allows you to apply some different, let's say, views to the map. So you can move the camera, select a views, and then build a sort of sequence of an urban environment. Then we introduce also the 3D measurement tools for the 3D part, that this it's sort of used in between, it could be used in between these views just to have some of more information of the feature that you have inside the map. Styling of vector data client side, that is a key point also for the use of 3D model combined with 3D tiles, because sometimes you will need to have, for example, a new project that you want to display in a 3D tile that it's the current situation. You want to show what will be in the future, so we introduce the way to apply a style to a vector layer, a point, and you can replace this with a building that it could be a model. And this brings us to the glTF, that it's an extension, that it's the extension for 3D model that we currently support. So if you want to test these 3D views, you could go to our repository. This is just to have a test. Here there is the link to the latest releases. There you will find a zip folder with a binary, and inside this binary there is two files, one for Windows and one for Linux, that you can start and try the application. Alternatively, if you have on macOS, you can use from the README of the repo, find the Docker instruction to set up and start the project. Once you start the application and you go to create a new map, you will find this visualization. And if you want to enable the 3D view, you need to click at the bottom. There is a toolbar with the 3D icon. This will switch from OpenLayers to Cesium, and then you can select the button in the sidebar, the last one. There is an eye with the two arrows. And this one will bring up the, on the left, top left, sorry, here, toolbar. And this toolbar is these views tools. The workflow of the views, so how you can set up. You can move the camera around by moving the mouse and find your location. Then by clicking the plus button, you will add a new so you will create your view. So at that point, it's like a sort of, it memorizes the position inside the map configuration. And those tools are enabled. There is the first part that is related to the editing of the view, because it's possible to add a new thing that we will talk later, but it's also possible to navigate through each view that you create. So create a new one, and then you can edit. Here are the edit options. So once you edit what you need, you can also decide that to show only one layer that is inside the map, then the second view another layer to show maybe a sort of sequence of events and not only the current situation of the map. Then when you create a new one, you start again. Plus, we'll add a new view, and you will have these visualizations. For the editing part, we introduce this different way to represent this view and also explain what's the content. The first part that you could edit is the description. It's a rich text editor. You can add also embed video or images or describe what it's inside or what we are seeing. We introduce also the possibility to review the position of the camera. So you can change view, then click on the button, the green button below to get the new one, or by typing in the input, you can decide which is the camera position by latitude, longitude, and height, and the target position. So you can fine-tuning the configuration. Animation, it's called animation that represents a transition in between views, because when you navigate with the tool on the right, there is a play buttons, and you can decide if you want a smooth transition or go in between this view right away. There is a second time gap that you can decide. We introduced the possibility to apply mask to 3D tiles. In urban planning, we noticed that some requirement was to have these 3D tiles. Usually, you don't update frequently that. So we will need to represent something new. We introduced the possibility to use a vector layer to put on top like polygons on the 3D tiles and then hide the part that you don't need. So this is done client side by mixing these two sources. And here you can decide if you want to revert the clipping, so only a place or multiple places are represented, or to get the holes or the place that you want to fill with your content. We introduce also the possibility to apply globe translucency to the Cesium library behind. This was useful when there was the needs to explain something that goes underground or underwater. So new construction, for example, a tunnel, a submarine tunnel, or the subway. If you want to represent something below, we needed a way to sort of, also by distance, to display what is behind the earth or the water surface. And this allows in the specific view to apply these options. Finally, once inside the MapStore, MapStore can add all the layers that they want, and those will be in a table of content. But here, for each view, you can decide to, for example, turn off the visibility of some of them, or turn on the visibility, the opacity, and an alternative to the mask system is the clipping system that could be also applied to the terrain, both terrain and 3D tiles. So the clip means that you can also cut a portion of 3D tiles and terrain. There is an edge case that you can use mask, and edge case that you can use the clip. So we introduce both to allow the user to decide what they prefer. Here's some example that we built with MapStore. The first one, the topic is a new project for urban planning. With the city of Genova, they had some new project in the city, and they want to describe what will happen and what will change in the urban environment. Here we get some of those main, let's say, points that will change, and something also about historical data. Here in this view, there is the red line represents the new submarine tunnel that they wanted to represent, and the yellow line represents two landmarks in the city. One is the lighthouse, and the other side there is the new waterfront that will be designed by Renzo Piano. Here, for example, we use the clipping method to take the 3D tile that are the current view of the city. We remove the portion of that the master plan represented. We use Blender to take the project and extrude the building. So it was really a low poly line mesh But to give the idea of the project, this we found inside MapStore, it helped also through the performance without to have for example, the bin building with ICF and so on. And this was a way to use a view to represent before and after a project. So one could use the first view to represent the current situation, then switch to the new one to see what's changing in the city. Here for the same area, we use always a model, glTF, taken from a bin file and to show the structure underground. So here it's used by clipping removing portion of the terrain, removing portion of the 3D tiles, and inside adding the new structure that will be built behind and to support the new project. Here, instead, it's a lighthouse in Genova, and in this case, they want to, it's sort of the representation of the urban environment that changed from the past to the present. So here, this hill represents what was in the past. They reconstruct a 3D tile with the hill relief that was before the new construction. So they want a comparison on what was before and what it's now. In particular, the red spot there represents the position that was the lighthouse before, and this is the combination of the two. So here it's done inside the client, and you can see these are two 3D tiles. Once that it's the past, it's the white one, and is the hill that was before, that was completely removed from the city, and the new one that we clip from the red box before represent what is now. So looking also the old image that could be done and added through the view from the description, one could have a comparison of what could be the state of the lighthouse in the past. A second example, and it's related to the use, so different level the city means, in this case, it was the underground. Always in the city of Genova, we try to reconstruct, to represent the relation between the subway station and the city itself. So to use these 3D tools to cut a portion of the 3D tiles and show the stations. To do this, here in this first image, we use a WMS layer with the hill shade that provided by GeoServer to visualize what is the relief of the hill shade of Genova, and then this this circle are all the stations that currently there are on the city. The interesting part here was to use the let's say representation and also use the animation in between the stations, so it could be see the sort of story in between this, that also we added some information that come from Wikipedia, and use this like cutting the station through a radius, I think was 150 meters, if I remember correctly. And then below the red line, it's a model of the, it's not in this case the right representation, but here we wanted to represent the line through a 3D model. So we added this glTF model file that we generated through Blender. And on top of the 3D tile, it's possible also to highlight some portion with vector layer, WFS, or GeoJSON shapefile that you can upload, and style them to highlight some elements. For example, here the roof of the station, or the station itself, where it's located and where the line goes. You can see that there is the transparency around, so we use that tool to allow to see through the terrain, so underground. I was mentioning initially that it's possible also to use multiple view and use this to facilitate and make more easier to measure. So if you clip some portion, you can focus on that and then use the MapStore tools that are available for each view to analyze some portion of the city. And here for the Cesium implementation inside MapStore, we included these 6 ways to measure the polyline, the area, so it's possible also to measure vertical surface to get a quote of an elemental features, and to take the distance from the terrain. If you have, you can include also a layered terrain that could come from DTM, for example, and then they use the 3D tiles on top and getting the distance in between, for example, the roof of a building to the terrain. And this give the measure tool gives a line of these differences. Then we introduce for the 3D that it's not available in the 2D environment, the angle measurement that, for example, they needed for the roof slope, the roof inclination and slope, and we included also the slope that could be computed by applying 3-point, a polygon with 3 points. As I mentioned initially, the clipping is possible to revert, so you can decide instead to show the station to cut a station and show what is behind. Now it's a simple model, but you could represent the complete model of the station with all the levels and show what will be built behind that. The last example that we try to do, because this one is like an experiment, we use the maps that was the Phos4G. And we try to represent this using 3D components that are available in MapStore, and with the fact that with the map views we can include videos and images inside this view. So here the idea is not to use the map views as a component that tells something urban planning related or in between component of the city, but to represent an event. So what changed in the city? Often happens that these events change the shape of the city, change the way that you access a city. So using step-by-step representation instead of fixed representation of a map, it could be helpful in some presentation or use cases. Here, for example, the background map is OpenStreetMap. And on top, we extracted also the building from OpenStreetMap, converted it to 3D model, glTF. And on top of those layers, here you can see that once you open the table of content, you see all the layers available. In this case, we had this one that was representing the different legends that we have inside. So the red building, that it's blue, but it's the red building, and all the accommodation and restaurant that was represented there. So it could be used also as static component. Here, we want to highlight the fact that if you add models that have a white material, that you usually in the 3D software, there is the possibility to apply material and it's completely white, you could apply colors directly through the MapStore style editor. So this allows you to have to change then finally your preference on the final visualization that you want. And in this case, the views was sort of a navigation in between those elements to represent what was there. So, yeah, 1 minute. Thank you.